Everyone built agents in 2025. GitHub Copilot, Cursor, Devin, Claude Code. The demos were incredible. Agents that could write entire code bases. Research papers proclaiming AGI was near. But here's what nobody told you. Most of those agents couldn't work for more than an hour without losing track of what they were doing. They'd hit the context limit, forget their progress, and start over. Or worse, hallucinate that they'd finished when they hadn't. 2025 proved agents can work. 2026 is about making them work reliably. And the answer isn't better models, it's better harnesses. This is the agent harness revolution. And if you're building agentic AI in 2026, understanding harnesses isn't optional. The shift from 2025 to 2026 represents a fundamental change in how we think about agentic AI. In 2025, the question was, can agents work? The answer, yes, for demos. We saw incredible 30-minute demonstrations where agents built applications, wrote code, completed complex workflows. In 2026, the question changed to, can agents work reliably? Can they work for 8-hour shifts? Can they complete projects that take days or weeks? And without proper harnesses, the answer was no. Agents that dazzled in demos crashed in production, hitting context limits, losing progress, restarting endlessly. This wasn't a model problem. GPT-4, Claude Opus, Gemini were incredibly capable. The issue was infrastructure. Agents needed persistent memory, session orchestration, error recovery, guardrails, and observability. By mid-2026, every serious AI team had shifted focus from building better agents to building better harnesses. Anthropic published their architecture. OpenAI demonstrated millions of lines of agent-generated code. Martin Fowler wrote about harness engineering as a distinct discipline. The shift was complete. 2025 proved agents could work. 2026 made them work reliably at scale. If you're building agentic AI systems now, you can't skip the harness. The harness is the system. So what exactly is an agent harness? Here's the key. The harness is not the agent. When people say AI agent, they usually mean the LLM, Claude, GPT-4, Gemini. But that's just the brain. The harness is the infrastructure that wraps around the agent to make it production ready. Think of it as the operating system for your agent. Your computer's CPU is powerful, but without an OS managing processes, memory, and I/O, it's useless. Same with agents. The harness manages 5 critical responsibilities. First, context management, preserving state across sessions. Second, session orchestration, deciding when to start-stop sessions. Third, tool integration, managing which tools the agent can access and enforcing permissions. Fourth, observability, logging every action for debugging. Fifth, guardrails, enforcing spending limits and preventing destructive commands. These 5 responsibilities make the difference between a demo and a production system. Without a harness, your agent is just an API call that forgets everything. With a harness, your agent becomes a reliable system that can work autonomously for hours or days. The harness is not the agent, but the harness is what makes the agent reliable. That's the foundational concept. Let me show you the fundamental problem harnesses solve: context amnesia. Agents operate in discrete sessions. Each session has a context window, maybe 200,000 tokens. The agent can work within that window, but when the session ends, that context is cleared completely. The next session starts with an empty context window. The agent has zero memory of what happened before. It's like waking up with amnesia. Without a harness, this causes catastrophic failures. Agents restart tasks over and over, never making forward progress. Imagine an agent building a dashboard with 5 charts. Session 1 builds charts 1 to 3, then hits the context limit. Session 2 starts with no memory, so it rebuilds chart 1 from scratch. Session 3 does the same. The agent loops endlessly, wasting time and money. Now, watch how a harness solves this. Session 1 builds charts 1 to 3. Then the harness saves progress to disk. 3 of 5 charts complete. Next, chart 4. Session 2 loads this from disk and continues exactly where Session 1 left off. No duplication, no lost work, seamless handoff. This coordination through persistent artifacts is the core pattern. The harness manages progress files, Git history, and session logs. Every new session loads these artifacts before starting work. The sessions are discrete, but the artifacts create continuity. They're the bridge that prevents amnesia. So why is 2026 the year of harnesses? 3 converging forces made this happen. First, models plateaued. GPT-4 to GPT-4.5 gave 15% capability improvement. Harness V1 to V2 gave 200% reliability improvement. The bottleneck shifted from model to infrastructure. Second, production requirements became unavoidable. In 2025, everyone built 30-minute demos. In 2026, companies needed agents that work 8-hour shifts without supervision. 80% of 2025 demos failed in production. The gap between demo and production was massive. Third, research and best practices caught up. Anthropic published their harness architecture. Martin Fowler wrote about harness engineering as a distinct discipline. OpenAI released case studies showing 1 million lines of code via harnesses. These 3 forces created the perfect storm. Infrastructure became more important than models. Use cases demanded reliability over raw capabilities, and the frameworks became available on GitHub. That's why harnesses went from advanced technique to foundational requirement in 6 months. Here's the proof. OpenAI's 5-month experiment shipped a beta product with 1 million lines of code, all agent-generated using harness orchestration. Not because they had a secret model, because they built the harness right. Let me give you a concrete example. OpenAI ran a 5-month experiment. Build a production app using agents with minimal human coding. 3 engineers provided guidance and reviewed PRs. Agents did all the actual coding. The results: 1,165,859 lines of production code across Python, TypeScript, JavaScript, CSS, and HTML. 4,247 Git commits, 892 pull requests, all autonomous. This wasn't prototype code, it shipped to a beta product. Here's what makes this significant. They didn't use a secret supermodel. They used Claude Opus and GPT-4, available to everyone. The difference was the harness. It coordinated 3 agents, managed context across 200+ sessions, integrated with Git and CI/CD, and enforced human approval gates. The harness maintained context persistence. When an agent session ended, progress was saved. The next session loaded that context and continued seamlessly. Over 200 handoffs, the work flowed continuously. This is production, not a demo. A beta product shipped to users, built by agents in 5 months. That's the power of proper infrastructure. OpenAI proved that long-running autonomous agent work is engineering, not science fiction. Here's the truth. Your model isn't the bottleneck. Your harness is. I know that's counterintuitive, but let me prove it. Take Claude Opus 4.6, one of the most capable models available. Run it 2 ways. First way, no harness, just raw API calls. Give it a complex task. For 2 hours, it's amazing. Writes code, makes progress. Then, it hits the context limit. Session ends, context cleared. Next session has no memory, so it starts over. Success rate on multi-day tasks, 23%. Second way, same model with a proper harness. First session works for 2 hours, then the harness saves progress. Session 2 loads that progress and continues where Session 1 left off. Sessions 3, 4, 5, seamless handoffs. Success rate 78%, more than 3 times better with the same model. The model gives you intelligence. The harness gives you reliability. In production, reliability beats intelligence every time. Reliability compounds. A reliable agent working 24 hours completes far more than a brilliant agent that keeps restarting. This is why companies are hiring harness engineers in 2026. People who understand distributed systems, state management, session orchestration, and observability. It's systems engineering applied to AI, and it's the most in-demand skill in the market. What goes into a production harness? 5 core components emerge from studying Anthropic's, OpenAI's, and open source implementations. Miss one, and you're back to unreliable demos. Get all 5 right, and you have production infrastructure. Component 1, context management. The hardest preserves state across sessions using progress files, Git history, and feature lists. These artifacts are written to disk at session end and loaded at session start. That's how continuity happens. Component 2, session orchestration. The hardest decides when to start new sessions, how to initialize them with loaded context, and when to terminate. This prevents context overflow while maintaining continuity. Component 3, tool integration. The harness manages which tools the agent can access and enforces permissions, rate limits, and error handling. It's the interface between the agent's intentions and the real world. Component 4, observability. The harness instruments everything. Every tool use, every decision, every API call gets logged with metrics. You can debug production agents because you have full visibility. Component 5, guardrails and recovery. The harness enforces spending limits, prevents destructive commands, and handles failures. These make agents safe to run autonomously. These 5 components are the skeleton of every working harness. Build them right, and your agents become reliable. Skip one, and you'll spend months debugging preventable failures. This is what harness initialization looks like in real Python code. The production harness class is the orchestration layer that wraps around your agent. It manages the entire lifecycle of long-running agent sessions. The initialization takes 2 parameters, the project directory where your code lives, and the task specification describing what to build. From these, it sets up paths to 3 critical artifacts that enable context persistence. First artifact, claudeprogress.txt, the human-readable progress log where each session writes its summary. Second artifact, features.json, the structured task list tracking what's complete and what's pending. Third artifact, init.sh, the environment setup script that runs at the start of every session. These 3 files are the foundation of context management. They're written to disk at session end and loaded at session start. Without them, you have context, amnesia. With them, you have perfect continuity across unlimited sessions. The harness manages these artifact paths automatically. The agent never needs to know where these files live or how they're structured. That's infrastructure's job. Abstract away the complexity so the agent can focus on the actual work. The initialize session method is where the harness configures the agent with tools, permissions, and guardrails. This happens before the agent writes a single line of code. First, it loads context from the previous session using load context. We'll see that in a moment. Then it creates an agent config object that specifies the model, Claude Opus 4.6, the project directory, and critically, the allowed tools. This agent can read files, write files, execute bash commands, and use the Puppeteer browser automation tool. But tools alone aren't enough. You need guardrails. The config enforces a $5 cost limit per session to prevent runaway API spending. It whitelists allowed commands. npm, git, pytest are safe. Anything else requires approval. It also defines forbidden paths, directories the agent must never touch. etc contains system configuration. scis contains kernel interfaces. Your SSH keys. The agent cannot write to these paths under any circumstances, even if it wants to. This configuration layer is what makes agents safe to run autonomously. Tools provide capabilities. Guardrails prevent disasters. Together, they enable reliable agent work without constant human supervision. The load context method reads artifacts from disk to restore the agent's memory. Remember, the agent session starts with an empty context window. This method populates it with everything the agent needs to continue work. The context object has 4 fields: task spec, the original project requirements; session history, what happened in previous sessions; completed features, what's done; and next steps, what to work on next. These give the agent both high-level direction and specific tactical guidance. If the progress file exists, the harness reads it and loads the full session history. This narrative log tells the agent what previous sessions accomplished, what challenges they faced, what patterns they established. It's qualitative context that structured data can't capture. If the features file exists, the harness parses the JSON to extract completed and incomplete features. Features where pass is true go into completed features. Features where pass is false go into next steps. Specifically, the next 3 incomplete features become the agent's immediate priorities. This context gets injected into the agent's initial prompt. Before the agent starts working, it reads, "Here's the original task. Here's what previous sessions did. Here's what's complete. Here's what you should work on next." Perfect context handoff. Zero amnesia. The usage example at the bottom shows how this all comes together in production. You create a production harness instance, pointing it at your project directory and giving it the high-level task specification. Then you call initialize session with session number 1 to start the first session. This is the initializer agent. It reads the spec, generates the features.json file, creates init.sh, and sets up the project scaffolding. Session 1 runs once and never again. Sessions 2 through n happen automatically. Each time a session ends, the harness saves progress. Each time a new session starts, the harness loads that progress and continues. The agent works for 2 hours, saves context, hands off. The next agent loads context and continues seamlessly. This pattern scales to dozens or hundreds of sessions. Anthropic ran 54 sessions to complete their clone project. OpenAI ran over 200 sessions to generate 1 million lines of code. The harness orchestrates all of it automatically. And here's what makes this production ready: observability hooks. The on-tool use callback logs every action. The on-session end callback saves progress automatically. You can see what agents are doing, debug when things fail, and maintain full audit trails of autonomous work. Let's talk real numbers from production systems. Anthropic tested the same agents with and without harnesses on multi-day coding projects. Without harnesses, 23% completion rate. With harnesses, 78% completion rate. That's 3.4x improvement from infrastructure alone. A startup building AI coding tools was burning $50,000 a month on API costs because agents kept restarting and duplicating work. After implementing a harness with context management, costs dropped to $8,000 a month. 84% cost reduction, $42,000 saved. Same capabilities, better architecture. Developer satisfaction jumped from 3.210 to 8.710 after harnesses. Why? Because agents became reliable teammates. You could assign a task in the morning and find it completed in the afternoon. No constant hand-holding or re-explaining context. Martin Fowler wrote that harness engineering is emerging as a distinct discipline. It's systems design, state management, and production operations combined. This is hard engineering, not just API calls. Every metric that matters, completion rates, cost efficiency, developer satisfaction, improves by orders of magnitude with proper harness infrastructure. This is the difference between agents being expensive toys and production-ready tools that deliver business value. What should you actually do? 3 takeaways. First, budget for the harness from day one. Allocate 4 to 6 weeks specifically for harness development in a 3-month project. Design the harness architecture before writing agent prompts. This isn't a bolt-on feature, it's foundational. Second, don't overinvest in model selection. Yes, models matter, but spending weeks evaluating models and days building your harness is backwards. Pick a good model, Claude Opus or GPT-4, and move on. A better model gives 10 to 15% improvement. A better harness gives 200 to 300% reliability improvement. Third, this connects directly to the 9 essential skills framework. Harness engineering is skill number 1, orchestration and state management. It also touches skill number 3, observability, skill number 4, memory, and skill number 5, context economics. Master this, and you're building competency across multiple essential skills. If you're hiring or upskilling, prioritize harness engineering. Agent infrastructure engineer and harness engineer roles are proliferating with senior-level salaries. This skill separates demos from production. Master harness engineering, and you're not just building better agents. You're building the infrastructure that makes AI work at scale. That's what matters in 2026 and beyond. In the next video, we're dissecting Anthropic's specific implementation, the 2-agent architecture, initializer and coding agent, the 4 core artifacts, features.json, init.sh, Claude progress.txt, and Git history. The session handoff pattern, exactly what gets written and loaded. Part 3 covers universal patterns you can use to build your own harness, regardless of model or language. The minimal viable harness, when to add complexity, and common mistakes to avoid. This 3-part series gives you the complete picture. Why harnesses matter, Part 1. What a proven harness looks like, Part 2. And how to build one, Part 3. If you found this valuable, subscribe. Harness engineering is a fundamental shift in how we build agentic systems. The teams that understand this now have a multi-year lead. Watch Part 2 tomorrow.